what? Then we compare the relative density. Then for the gas X, we have this because we don't know it. And then for carbon 4, we have 44. So what are we doing next? And the best way to go about this is to square both sides. So remove the square root. So when we square both sides, what we have here, let's just finish up. We have squared over 40 squared. That will give us all over. Okay, this is no more. It's gone. So then cross multiplying, if you cross multiply this, what we will have is relative molecular mass of that multiplied by 40 squared equal to 27 squared times 44. Then making the relative molecular mass of the gas S the subject of the formula, we have 27 times 27 times 44 all over 40 times 40. So that's what we are going to be working with. So let's see how far we can go with this. 27 divided by so what we have will be relative molecular mass of this will then be everything will give us 20. That is 20. That's the last answer here. The final answer here is what? 20. So now, as you can see, we can use the. So today we are going to be looking at Gay-Lussac's law of diffusion. We know that Gay-Lussac's law of diffusion says that the rate of diffusion of any gas at STP, that is at standard temperature and pressure, is inversely proportional to the square root of its vapor density. So today we're going to be looking at some calculations that will help us understand some basic calculations we are likely to expect in any question regarding to what the results. So we have about 3 questions we're going to be looking at. I want to encourage you to give your time to this. I want you to watch this into the end so that you'll be able to see how you can handle some of these questions. The first one we have here, and before I continue, these questions will also be in the description section, and I want to encourage you to watch. Make sure you leave your question there. If there's any question you have for us, make sure you leave it as a comment there, and then from the description section of this video, you are going to see all these questions so that you'll be able to really follow as we are solving it together. So now let's continue and look at this and look at what we have here. The first question we have here: 50 cm cube of hydrogen diffused through a porous pot in 10 seconds. How long will it take 150 cm cube of chlorine to diffuse through the same pot? Now we have the atomic mass of hydrogen and atomic mass of chlorine. So what we are doing here, what we are looking for now is the time, and we know that from what we have, we know that rate of diffusion is inversely proportional to square root of P vapor density, and this vapor density also is the same thing as vapor density. 2 times vapor density will give us relative molecular mass. That means that what it simply means is that one relative density is also square root inversely proportional to what? Square root of what? Relative molecular mass. That is what it also means. But then another one we should also put across here is that since we know that rate is equal to is inversely proportional to time, it also means that if we are to compare these things, if we are to compare, since we are looking for time, if we are to compare it based on what we have here, our time of diffusion will have, if we are comparing the two gases now, the time of diffusion will then be 1, that rate of time of diffusion of gas 1, and time of diffusion of gas 2 will be equal to let's say, let's use the density rate of vapor density of gas, square root of vapor density of gas 1 over what? Square root of the what? Vapor density of gas 2. That is what we will have. So let's quickly go there. But before we solve this problem, you note something here. 50 cm cube and diffuse in 10 seconds. Now we're looking at 150 cm cube of the gas, how long it will take. That means before we can solve this thing, all of them should be in the same volume. Because the volume of this is different from that, we cannot get exactly, because since we are comparing the two gases. So to make it to be the same, we can find out how many volumes, how long it will take the same volume, that is 150 cm cube of this hydrogen to pass, to diffuse through the same word ports. So what we're going to do here first is to find out. To find out is that since we know that 50 cm cube of this hydrogen diffused through what, we have 10 seconds. 10 seconds, then 150 of the same gas, which is hydrogen, would then be 10 over 50 times 150 over 1. This will cancel out this, that we have 3 times 10, we have 30. That means 30 seconds. It will take 30 seconds for the same volume of hydrogen to diffuse through there. So now we can substitute for this our formula we have here. This formula we have succeeded in getting out. Then for hydrogen, we can call hydrogen the gas 1. We have it 30 seconds over what? The chlorine, which we don't know, we're looking for. Then the vapor density of hydrogen is 1, while the vapor density of the other chlorine is what? Is 35.5. So what we do next now is to, remove the square roots. If we are removing the square roots, we square both sides. When we square both sides, what we have is 30 over what? 30 over time for chlorine equal to 1 over 35.5. Then when we cross over this is square, 30 squared. This 30 squared will give us 90, 900. Yes, 900. I hope let me really confirm it. We have a 3 square, 30 square will be okay, 900. We have 900. Oh, this one is squared, 2 squared. Don't forget to put that. So we have 900 times 35.5. So when we multiply to 900, 900 multiply 35.5, what we have will be, it will give us, it will give us 33, that is 3, so that's what we have. So now to get the time of diffusion of chlorine, we then squaring this. When we get the square root of, we have is equal to 178.7 seconds. That is what we have. So this is what we have here for the time of diffusion of this chlorine at the same, from the same porous port. That is 250 cm of the chlorine will diffuse through that. So that's what we have here. So now the next one we're going to be solving here is say that the relative rate of diffusion of a gas X compared to carbon 4 is 27 to 40. Calculate the relative molecular mass of the gas. Now, the first gas we have there is carbon 4. Carbon 4, we have carbon 4 there, and the other gas we're looking for is the second gas, which has a relative molecular mass unknown. So let's see how we're going to be solving this. We know actually the rate is always So this is what we have here. So based on this very relationship, we can say that since we are comparing the rate that of carbon, the rate for carbon 4 is what 27, while the rate for the gas X is what 40. So the relative molecular mass of carbon 4, carbon relative molecular mass of carbon 4 is what 44. Is already given to us here, 44. So the relative molecular mass of this gas S is what we are looking for. We can put question mark here. So looking at this, we can use this formula since we are looking for the relative molecular mass. The other one we use the vapor density to solve it. Here now we're using the relative molecular mass. We're using the relative molecular mass of those compounds. So now let's look at what we have. By substituting, we have 27 for carbon, and then 40 for the gas S, which is the same thing as what? Then we compare the relative density. Then for the gas X, we have this because we don't know it. And then for carbon 4, we have 44. So what are we doing next? And the best way to go about this is to square both sides. So remove the square root. So when we square both sides, what we have here, let's just finish up. We have squared over 40 squared. That will give us all over. Okay, this is no more. It's gone. So then cross multiplying, if you cross multiply this, what we will have is relative molecular mass of that multiplied by 40 squared equal to 27 squared times 44. Then making the relative molecular mass of the gas S the subject of the formula, we have 27 times 27 times 44 all over 40 times 40. So that's what we are going to be working with. So let's see how far we can go with this. 27 divided by so what we have will be relative molecular mass of this will then be everything will give us 20. That is 20. That's the last answer here. The final answer here is what? 20. So now, as we can see, we can use the Graham's law to get the relative molecular mass. We can also use it because we remember by using the vapor density in solving the last problem, it means that we can also use the law to calculate the what? Vapor density if the rates are given. If the rates of the two gases are given to us, we can also calculate that. Then the final one we have here said a 50 cm cube of a gas Y diffused out in 5 seconds, and 150 cm cube of another gas Z diffused in 10 seconds. Calculate the rate of diffusion of the two gases. Now we're looking at the rate of diffusion of the two gases. Rate of diffusion of the two gases, that's what we're going to be solving now. So the rate of diffusion of the two gases, you know that rate is equal to volume over what? Time. Over what? Time. So we have for the gas what? We have gas Y. Rate of diffusion of gas Y will then be, we have the volume of gas Y is equal to 50, and the time is equal to what? What do we have as time? 5 seconds. Then based on this our formula, we can say that 50 over what? 5. That will cancel out. We have what? 10 cm cube per what? per second. Then cm cube per second, that is the rate. Cm cube, yes, the cm cube per second. So the next one we have here, then the second one, in the same vein, we have 150 gas y, z now, this is gas z. Then we have 150 over what? 150 over 10. Then we'll cancel out. If we cancel out, what we have here will be 15 cm cube per second. That's the um, that is what we have. So I thank you for being part of this class. If you have any question, you can leave it in the comment section. If you have not subscribed to our channel, we encourage you to do that. Subscribe to our channel, and then if you have any you don't forget to share so that it will get to other of your friends or any other person that will need this information we have here. So thank you so much.